So for this factoring of polynomials lesson here, we're dealing with quadratic form. We factored quadratic functions. What we're dealing with here is polynomials that take the form of a quadratic but aren't quadratics, right? Quadratics are polynomials of degree 2. Okay. So before we get into like the quadratic form, let's just look at another example of a factoring polynomial, which, we could look at this as quadratic form, but I tend to not think of this one as necessarily quadratic form. So we're factoring negative 16 n to the fourth plus 625. Okay. When you look at this, you say, well, clearly that's not a quadratic. Does it look like a sum or difference of cubes, difference of squares? Those are a monomial. One of the things I'm going to suggest is this leading term, the highest power term, the n to the fourth, it's negative. So if that's the case, I would strongly urge and suggest that we factor out a negative 1. So that is a monomial we can factor out, which leaves me with now 16 n to the fourth minus 625. Okay. Now, we factored. Now we look at this and we say, does this factor in? A lot of the factoring depends on how something looks, and then you have an understanding of, depending on how something looks, different ways that it might factor, whether it's a sum of cubes, difference of squares, if there's a monomial, if it's a factoring or quadratic. So when I look at this, I see a minus. I only see two terms, right? 16 n to the fourth and 625. 16 is a perfect square, so I start to think, question mark, is this a difference of squares, a squared minus b squared? Because if it is, then that factors nice into a plus b times a minus b. Okay, so I might think to rewrite this just to see if it's a difference of squares. And to see it, I got to say to myself, well, what do I raise to the second power to get each of those terms? So what can I plug in here, squared, to get 16n to the fourth? Well, 4n squared works. 4n squared times 4n squared would be 16n to the fourth. And what do I plug in here to square to get 625? And I get 25. So that is a difference of squares. Okay. So now what does 16n to the fourth minus 625 factor into? Well, here I have a squared minus b squared. And we know that a squared minus b squared is going to factor into a plus b times a minus b. Don't forget to bring that negative 1 along. So I got negative 1 times what? Well, I have 4n squared plus 25. And then over here, 4n squared minus 25. Always double check as you go and say, can I factor negative 1 anymore? No. 4n squared plus 25. No. 4n squared minus 25? That's a yes, right? Because that's another difference of squares, right? 4n squared I can write as what? 2n to the second power. 25 I can write as 5 to the second power. So I have another difference of squares. So that means I'm going to have negative 1 times 4n squared plus 25. And then over here, another difference of squares, 2n plus 5, and then 2n minus 5. And now every one of those factors, if I check, I can't factor anymore. So therefore, my original polynomial is completely factored. Those are the factors that when multiplied will give me the original polynomial function up top that I have here, the negative 16 to the fourth plus 625. Okay, so those are in this case, 3 polynomial factors of negative 16 to the fourth plus 625. Okay, so it's technically a quadratic form, but that one I look at more so as just recognizing that difference of squares and how you got to rewrite it to identify what those individual little bases are, the things that you need to take on this form for the difference of squares. Now, when we get into quadratic form, right, what's a quadratic function? Well, quadratic function, this is actual quadratic function, okay, in x, in terms of x, right? Quadratic function would be what? Something along the lines of ax squared plus bx plus c, right? That's my quadratic function in standard form. Okay, that x is being squared times a, bx and c I may or may not have, but this is the defining characteristic of the quadratic function, the ax squared. Okay, now quadratic form, okay, Quadratic form, okay, is that we're going to say let u, right, be, we'll say a function of x. So that means u might be x, but u could also be some other function of x. It might be x squared. Maybe u is x plus 2, okay, stuff like that. So then if that's the case, then quadratic form would be, all right, so here's what quadratic form is a u squared plus bu plus c. So that's quadratic form when we're talking about u being some function of x, okay? And that might be a little confusing. So let's look at just a couple examples of what a quadratic form would be, right? So suppose here in this first one, I'm going to let u be equal to x squared, okay? So u would be x squared. So if I replace u up here in this quadratic form with x squared, then I would have what? I'd have a times x squared squared plus b times x squared plus c. So that's quadratic form because I have a times something squared plus b times that same something that's being squared over here. Now in the end, we have this, right? Which clearly when you look at this is not a quadratic function. The highest power is not 2, the highest power is 4. But this is quadratic form because working from here backwards, I could rewrite it to make it kind of like a quadratic. Meaning a, again, times something squared plus b times the something. Notice these things here, what's being squared here and what's multiplied by b are the same. That's one of the ways you can identify that something is quadratic form, okay? So that's one example of a quadratic form, all right, what it looks like, okay? Here's another one. All right, now we'll just kind of start the end. All right, say, what about this? What about a x to the 6th plus b x cubed plus c? You say, is this quadratic form? Well, if it's quadratic form, then that means I would have to be able to write this as a times something squared plus b times something plus c, where the somethings in those parentheses are the same. If the somethings in those parentheses are the same, then that takes quadratic form. And then stuff we do with quadratics, factor, solve, we can apply to this non-quadratic function, okay? In this case, well, what do I square to get x to the 6th? Well, x to the 3rd, right? Powers to powers, we multiply. And then over here, well, clearly I have b x to the 3rd. So this takes the form of a quadratic. Therefore, this right here is also in quadratic form, okay? Let's do one more just so you kind of get a sense of what quadratic form looks like. All right, so the third one here would be, let's go with this one. Suppose let's throw a number in there now. Let's go with 2 times x plus 3 to the 8th plus 3 times x plus 3 to the 4th plus 5. And it almost looks like a quadratic in the sense of, I think, a number times something to a power plus a number times something to a power plus a number, right? Kind of takes almost the form of a quadratic right away. But if we're going to really identify this as quadratic form, then I got to think, can I write this as 2 times something squared plus 3 times something plus 5? And again, that the somethings in the parentheses would be the same. So what do I square to get x plus 3 to the 8th? Well, x plus 3 to the 4th. All right? If I take x plus 3 to the 4th to the 2nd, I get x plus 3 to the 8th. And then over here, 2 times x plus 3 to the 4th. 3, right? So this takes quadratic form. All right? And we can really see it if now, we work one way, now we're working a different way. If I go on the side and say, well, what if I let u, that letter, u, that variable, represent this quantity here, x plus 3 to the 4th? That means anywhere I see an x plus 3 to the 4th, I can replace it with u, in which case, what does this become? 2. That x plus 3 to the 4th becomes u, 2u squared, plus 3 times this whole thing becomes u plus 5. And you can see there's my quadratic form, right? This really looks like a quadratic function. It's just in terms of the letter u and the variable u, not x. Okay, so that hopefully that builds up the intuition of what quadratic form is. Okay, because you got to be able to identify quadratic form to then apply skills and techniques and concepts to the quadratic form polynomial. So over here, the first way what we're going to do is just we're going to factor, right? Okay, again, how does something look? A way to proceed. So factor x to the 10th plus 5x to the 5th minus 6. Okay, so when you look at this initially, it should look like a quadratic form almost already. I have 3 terms, okay? And if it's quadratic form, then just kind of like we did with some of those factoring patterns, I want to think, can I write stuff in parentheses that's the same? Can I put something here, and they have to be the same to be equivalent to this? So in other words, what do I square to get x to the 10th? X to the 5th. Plus 5, well, clearly you see here what? X to the 5th minus 6. And you can see that, well, clearly that's now quadratic form. Okay, so now we're going to factor this. All right, now, here's one option we can do. We can go on the side now and just let u be equal to this stuff right here. Okay, so let u be x to the 5th. All right, now I rewrite this here as x to the 5th becomes u squared plus 5u minus 6. So this becomes now something that looks much more familiar to us. All right, this I know how to factor. When I look at that, I go, oh, I factor quadratic. This is the quadratic function in terms of the letter u, the variable u. So what do? I say factors of 6 is subtract the 5. Oh, it works. All right, what's going to work? U and 6, u and 1. Signs are different. Different signs. Plus goes with the bigger number. Plus, minus. There, I factored this one. That was kind of easy. But keep in mind, we're trying to factor ultimately this one up here, which is in terms of x. So now all we have to do is, we're in terms of x. We recognize it as quadratic form here. We did this little substitution to get this to look familiar to us. And now we want to get back in terms of x, which is a matter of just, well, summing back in place of u, x to the 5th. So u plus 6 becomes x to the 5th plus 6. And u minus 1 becomes x to the 5th minus 1. Okay. And now we say, does this factor anymore? Does this factor anymore? The answer is no. So we have factored that quadratic form. Okay. We factor it basically using the same technique that we did for factoring quadratics, even though it's not a quadratic function, but it has the form of a quadratic function. Okay. Let's look at another one. So another one, factoring, right? We're factoring this completely. Let's go with 3p to the 8th plus 15p to the 5th plus 18p squared. Okay. So if we look at those, and I look at it kind of looks like a quadratic, but first we always want to be thinking monomial. What's in common here with those 3 terms? Well, take out a 3p to the 2nd. What's left? Divide here, I get p to, now be careful. All right, I'm dividing out. All right, don't divide 8 by 2, because when I multiply, what do I do with the exponents? When I multiply p squared times p, I add. So if I'm taking out and dividing out a p to the 8th, I'm really taking p to the 8th divided by p to the 2nd. That's going to be equal to what? It's not going to be p to the 4th, right? This is what I have. I have p times p 8 times up top. I have 8 p's multiplied. Down here, I have p times p. I have only 2 of them. So 2 are gone. What leaves me with what? 6 p's multiplied. So p to the 6th plus 5p to the what? 3rd. And then plus 6. So we factored out this monomial. Now you look at this right here. Is that quadratic form? It looks like it might be a quadratic. There's 3 terms. Okay. And hopefully we start to recognize that this is quadratic form pretty quickly by saying, well, that's what? P to the 6th is the same as p cubed squared plus 5p cubed plus 6. All right. Now at this point, you have an option. If you recognize this as quadratic form, I don't need to do a substitution on the side. You don't need to do this. It's not a bad idea to understand what's going on here, rewriting it to make it simpler and more familiar, because later on down the line, you get into calculus, we do this often. It's sometimes very necessary to do a substitution type thing. But here, you could do that, right? So one option would be let's take this and write it as u squared plus 5u plus 6. We could do that on the side, okay? Or if you recognize here, then that means, well, this is what's going to be in front, the p cubed. Either one. So if I go over here, I say factors of 6 to add to 5, right? Well, it works. It's u plus 3, u plus 2, and then replace your u with, well, what it is, p cubed. And then I would have what? I'd have that this factors into p cubed plus 3 times p cubed plus 2, right? And you could get that right from here once you recognize this from here, right? The better you get, you could cut down some of this work. Don't forget to bring this along. If you don't write down in front, you're not correct, okay? And like I said, every state you say, does this factor anymore? Nope. Is this sum of cubes? Is this a sum of cubes? A p cubed plus, it looks like it, but then 3? No. Okay, it's the thing. You see stuff, you start to think, it looks like a sum of cubes. How about this sum of cubes? Here it is. No, 2 is not a perfect cube. So that means we're done, okay? So that's the factoring of quadratic form, okay? Could be kind of a little confusing to start. Just make sure you look this over. Pay attention to some of the things I'm describing. All right, pause, rewind, watch again, okay? If there's anything you don't understand, you got to make sure, make a note of it. The video, right? What time, maybe what I was talking about. We can get together and either through email, can answer the question, or we hop on a Zoom and I can explain it further, okay? So let me know if you have any questions.